Hi, and welcome to this video on graphing quadratic functions. In this video, we're going to focus on non-parent functions in the form y equals ax squared plus bx plus c. So that would be the standard form of a quadratic equation. So we've learned that the parent function for a quadratic is x squared. However, when we have a non-parent function, our function is f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. Okay, so either of those notations are okay. We're going to talk about in this graph, we're going to be focusing in detail on the parabola. We know that the type of the graph is a parabola, and it's U-shaped, and it's also symmetric. And that's very important to us because that's going to actually help us find other important things about our graph. Okay, so if a graph is symmetric, we know it has a line of symmetry, and that is a line that passes through the middle. So if I have a parabola that looks like this, the line of symmetry is the imaginary line that passes through the middle. And that line that passes through the middle also hits the parabola at the vertex. So the vertex is on the axis of symmetry. So once we found the axis of symmetry using the equation x equals negative b divided by 2a, we can actually take that x value and plug it into the f of x value. So for instance, if I have x equals negative b over 2a, I can take that and plug that x value in. So this x will replace this x in the original function. And so what I'll be doing is actually finding the y value of the vertex. And so it'll give me a point for the vertex, which is xy. And that x represents the line of symmetry, and then the y represents the y value at the line of symmetry. And we'll talk more about that. And we'll also be looking at whether our vertex is a maximum or a minimum. So that means if the parabola is turned concave down, so facing downwards or going down, the vertex is at the top and it's a maximum. Of course, if it's turned the other way, then it's a minimum. Okay, we're also going to be looking at the y-intercept, which is where the graph crosses the y-axis, so the vertical axis where the parabola crosses it. And then we'll also be looking at the x-intercepts, and if we have any. So we've been talking about discriminant and how to determine how many x-intercepts you have and all of that. Okay, so in this video, we're going to start off with a problem. And so we're going to look at one example that we did, and we're going to use this one. So it says, let's graph the quadratic function y equals x squared plus 3x minus 4. Well, in this graph, it says find the axis of symmetry and draw a dashed or vertical line, so a dashed dotted line. All right, so in order to find the axis of symmetry, we learned that we have to use the formula x equals negative b all divided by 2a. And that will tell us where the middle of our parabola is. Well, first we have to identify our coefficients. So if our equation is given to us in standard form, then we can identify our coefficients. So for the first one, a, the coefficient a is 1, the coefficient b is 3, and the coefficient c is negative 4, okay? All right, so what we're going to do is use these coefficients in the formula x equals negative b over 2a in order to find out where the middle of our parabola is. Where's that imaginary line? So we have negative, and then b is 3, all divided by 2 times a, which is 1. And so when we put that in and simplify it, we get negative 1.5. All right, so it says use the axis of symmetry to find the vertex. So use the axis of symmetry to find the vertex. And then we're going to plot it on the graph. But let's go ahead and plot our axis of symmetry first. It's at negative 1.5, so we know it's about here. So it's going to be between negative 1 and negative 2, so right between those two x values. Right, if we're looking at our axis, this is our x-axis, this is our y-axis. And so if our axis of symmetry is x equals negative 1.5, well, x of negative 1 is here and x of negative 2 is here, so 1.5 would be between those. And so that imaginary line, meaning that all the x values on that imaginary line are negative 1.5. So now we're going to find out where exactly the vertex of the parabola is. Okay, we know that the x value of the line is 1.5, but let's find out where on the parabola, on this axis of symmetry, our vertex is. So in order to do that, we're going to take our original equation, f of x is equal to, and it looks like we have x squared plus 3x minus 4. And what I'm going to do is I'm going to use this x value in this equation in order to find out what the vertex is, because that's going to give me the y value on the axis of symmetry. And remember, if I have a function, then I can only have each x value has to be paired with one y value. So that means that if I find the y value on the axis of symmetry, then that particular point is going to be my vertex, and that's the only point that's on that line. of symmetry. Okay, so let's plug in our axis of symmetry, our x value. Negative 1.5 is equal to negative 1.5 squared plus 3 times negative 1.5 minus 4. So notice that I'm replacing all of my x values with negative 1.5. Okay, so go ahead and calculate that. Take a minute. You can pause the video if you need to. Okay, so you should have gotten that f of x was equal to, or f of negative 1.5 is equal to negative 6.25. So that would create a vertex that has the point negative 1.5, comma, negative 6.25. Remember that the vertex is a point. So if you just give the axis of symmetry, you haven't given the vertex. So let's find out where that point is on the graph. So I'm going to zoom in a little so that I can actually graph that point. And if it's negative 1.5, I know it's on this line, and then it's negative, the y value is negative 6.25. So I'm going to go down 1, 2, 3, 4, 5, 6, and negative 6.25 is about a fourth of the way after negative 6. So it's about there. Okay, so now I have my vertex. So my parabola could either open down or it could open up. More than likely, it's probably going to open up. And if we find our y-intercept, that'll actually tell us what direction it's going to be going. So let's find our y-intercept. Remember that the y-intercept is where the graph crosses this axis, this vertical axis here. So y, or f of x is equal to, well, remember, I'm going to use f of x in this case. So f of x, or something, right, is equal to something squared plus 3 times something minus 4. Well, what is that something? What is the x value on the y-axis? If you guess 0, then you're correct. So what I'm going to plug in is an x value of 0. And so that's going to give me negative 4. So f of 0 is equal to negative 4. That means that my y-intercept is 0, negative 4. So it crosses, the parabola crosses the axes, the y-axis at negative 4. So 1, 2, 3, 4. And there's the point 0, negative 4. Okay, well, if you're not sure how we got 0, negative 4, you're basically, remember that the x value is 0 on the y-axis, so you can plug it in. Or you can also note, if your equation is in standard form, in the form y equals ax squared plus bx plus c, then this value here, c, only in this form, is actually your intercept. So notice here that c was negative 4, and so when we plugged in 0, we ended up with negative 4. Why does that happen? Well, if you have x squared, and it's 0, and 3 times x is 0, if all your x's are zeros, then these terms here will all cancel out and become 0 because you're going to multiply them by 0. Okay, so we have 2 points so far. Let's actually get a third point before we go on to find our x-intercept. So we have where it crosses the vertical axis. Now we want where it crosses the horizontal axis. But let's go back to something about symmetry. Remember that this imaginary dotted red line is my line of symmetry. And so what it is it's the middle of my parabola. So whatever points that I have on either side of my parabola, other than the vertex, then those points will be the same distance on both sides. So for instance, the vertex is on the line, but notice that the y-intercept is actually what we went over, negative 1.5. So it's 1.5 away on the right side. So if I go to the other side, 1.5, so 1.5, then I should have a point right there, and you can see that they should mirror. So it should be the same on both sides, and I can see the formation of my parabola there. Okay, so now we want to find out where it crosses the x-axis, so that's the horizontal axis. So we need to, first of all, find out if it has intercepts. We can assume that it is because it's opening up this way, and we know it's not finished. But just in case you didn't know, if you decided to do all your points at the end, then let's use the discriminant. So we learned that the discriminant is b squared minus 4 times a times c. And so that's just the part that goes under the quadratic formula. So if we're going to use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Well, this b squared minus 4ac is going to predict to us whether or not we have x-intercepts. Okay, so let's plug in those values. We know that b was 3, so 3 squared minus 4 times a was 1, and then c was negative 4. Well, I end up with, it looks like 9, and then negative 4 times 1 is negative 4, and then times a negative 4 would be a positive 16, so plus 16, and that equals 25. Well, remember that if this is greater than 0, then we have two x-intercepts. So since we found that we have two x-intercepts, then we need to go ahead and find out what those intercepts are. So let's put this into the quadratic formula. Well, x is equal to, we said that negative, or b was 3, plus or minus the square root. And since we already found the discriminant, which is this part under the radical, let's just go ahead and put that value in, which is 25. So plus or minus the square root of 25, all divided by 2 times, and a was 1. So now let's simplify that. So x is negative 3, plus or minus the square root of 25 is 5, and that's all divided by 2. So then let's simplify it even further. Remember that I have two options for my intercept, so I'm going to come over here, and I'm going to say x can be negative 3 plus 5 divided by 2, and x is also negative 3 minus 5 divided by 2. Remember that I have to find both if I have two intercepts, so I have to test both the positive and negative case of adding or subtracting the discriminant. Okay, so I have negative, or the square root of this, the discriminant, excuse me. Okay, so I have negative 3 plus 5, which is 2. So that would give me 2 divided by 2, which is 1. And then I also have negative 3 minus 5, which is negative 8 divided by 2. And so that will give me negative 4. So my x-intercepts are at 1, 0, and negative 4, comma 0. So let's go ahead and put those on our graph. So 1, 0 would be here, and then 1, 2, 3, 4, negative 4, 0 would be there. So I can go ahead and extend my parabola up. Now I know my parabola will continue on, but since I have 5 points already, I have a good idea of what my parabola is doing. So all it's going to do is continue. But what I need to make sure that I do is to actually label those important points. So the important point here would be the vertex, and that one was negative 1.5 comma negative 6.25. That's a very important point. And then of course the y-intercept, which was 0, negative 4. And then of course the x-intercepts are important, which was 1, 0 on this side and negative 4, 0 on this side. Okay, you can choose to label this point, this extra point that we found, by using the rules for symmetry, or not. But if you did label, it would be negative 3, comma negative 4. Okay, so we have 5 points graphed and 5 points labeled on our graph, and so you guys need to make sure that you're doing that when you're actually graphing these. And we have one last question. So it says analyze and determine if the vertex is a minimum or a maximum. Well, we can see that our parabola is facing up, so it's turning up like a smile kind of. And so the vertex is the minimum point. It's the lowest point on our graph. So if we were to take the range would start at our vertex and go on forever. So since it's the lowest point, that makes it a minimum. So our vertex is a minimum. Right, minimum. Oh, I keep writing the M again. Okay, so it's a minimum, and the value of the vertex, or the point, is negative 1.5, comma, negative 6.25. And that is the minimum value of our vertex. All right, so I hope this video has helped a little bit in helping you actually graph these. And just be careful with your math, and integer mistakes and things like that are always the things that get in the way. So just be careful when you're adding and subtracting negative numbers, multiplying and dividing negative numbers. Don't let those mistakes throw you off. All right, I hope this video has been helpful, and see you in the next one.